First, we will start by compiling the program. As you can see, there are any errors or warnings. Now we will demonstrate the code walkthrough.
So the first important part of our code was doing get opt to make sure that we could get the input correctly and implement it as variables for the rest of our code. Initially, we had actually done a completely different method of getting the input, which was a lot more complicated, and when we were able to figure out get opt, it was so much simpler, and it reduced our amount of lines of code substantially. So that was really beneficial for us. But it was pretty simple, just making sure that we could take two cases, one for the delay and one for volume, and assigning it to the proper variable and converting it as necessary so that it could work with our types for the rest of our program. And it got rid of a lot of input validation, as you will see in our test cases. Our default values that we set at the top of the file to ensure that even if no parameters are passed in, the program still works properly for parsing the WAV file. And even for getting in the input files and the output files, we have our own input validation that works in terms of which arguments are passed in.
Another significant portion of our code is editing the header. We have to edit the 2nd and 20th shorts within the header to make sure that we expand the file size when we add the delay to account for the added time. And in this code, you can see we use a pointer in the header to point to the 2nd and 20th shorts that we need and to add delay times 2 to their value as specified in the instructions.
Another significant part of our code was writing the while loop for the first delay samples and accounting for basically everything before the x0 samples that we're supposed to write at the end of the code. How we implemented this was by creating a buffer and a reader array. The buffer array stores the volume scaled samples, and the reader array keeps the most recent samples from the input file. So here we're writing the scaled original samples into the buffer, and the reason we put this outside of the while loop is for the first however many delay samples that don't need to have echo added to them, we can still store them in the buffer and then add them with the original samples that we store in reader. And this works because the while loop will continue to write into the output file from the buffer and also scale the volume again. So this loops until the first. So the while loop will continue reading in delay blocks until it can't loop through it anymore. And then that's where we have the rest of our code to account for the remaining input samples, mod delay chunks.
So after the while loop has terminated, this next section is basically trying to take everything that's left in the buffer and trying to output it into the output file. And so how we do this is we take a variable called samples left that essentially figures out how many samples are left in the buffer, and we use that to essentially empty what's left in the buffer and put it out.
We read the remaining samples left and combine them with the buffer to make sure we finish the mixing portion of the sound. However, we need to account here for the delay that's left over because we did increase the size of the file, and so delay will be longer than the original sound. These last couple of elements will be not mixed, but they'll be scaled and written to the output file. So now our buffer is empty and our file is read through, so we free both of our buffers and reader and then close the files.
Now we're going to show some examples that we have for our comprehensive testing of our program. First, we're going to do some input validation testing.
First, we're going to try doing the welcome.wav file.
Welcome.
As you can see, you can hear the echo at the end, but however, let's try it with the door.wav file. If we compare it with the original, there's not much difference in sound. This was an issue we unfortunately found out towards the end of our coding, and we realized that our echo works on certain WAV files and not for others.
For example, with the welcome echo file, we have this sort of doubling effect showing that there is some kind of an echo. Trying to figure out at what position we need to put the echo samples was not really working generalized for all of the kind of samples that we were using. With our crow example even, try and run it with that one. we can see, although the start is pretty similar, we can hear that echoing happening near the very end.
So now we're going to try running add echo with our short.wave file. And then as you can see through our print statements that the elements that are mixed in, or the samples that are mixed in, are actually correct according to the expected output seen on the assignment page. However, after a lot of debugging and trying to trial and error working our way through our code, we are unfortunately unable to figure out why it works for certain files and why it doesn't work for others.
This was a difficult lesson for us to learn, as we thought our testing at the beginning was good with our print statements, or because it was helpful. It did help us understand what was going on, but it's not comprehensive enough for such a difficult program to understand. When it comes to things like using bytes and making sounds, print statements just aren't enough. And unfortunately, we learned our lesson too late, but we've done enough that we've learned a lot throughout this project, and I'm sure the lessons we learned were more important than getting the finished result at the end of the day. And we're really glad to have this opportunity to finally seriously apply the skills we learned in class and feel what it's like to work on a team, to have this simulated work environment. So now we're going to talk about a few of the issues we encountered, and the first one was the header.
Yeah, so the header was a little bit tricky to find out, to figure out how to implement. Our biggest difficulties was definitely trying to figure out really how the implementation of the unsigned integer was most effective in this situation. But we were able to figure out kind of how to use pointers and how to dereference them in the correct way to ensure that all the necessary information was being transferred from the input file into the output file.
Do you want to go? I can go
Go
on
for it.
it. But yeah, we tried a bunch of different things while trying to write into the header. One of it was first f-seeking to the location of the 2nd and the 20th short in the header array. However, that didn't work. We also tried array indexing, but finally the solution that we arrived at was using a pointer to access the location of the 2nd and the 20th short, and then putting that as an unsigned integer, and then adding the delay times 2 to that.
Yeah, it was a little bit tricky trying to figure out whether our header was working or not, because we continuously was getting, when we were trying to open the files, it would say that it was encoded incorrectly and it just wasn't able to open it or do anything. And that was really troubling for us because we just couldn't figure out why it wasn't working. But after a while, as Usha mentioned, we were able to figure it out, and yeah.
Yeah, but even at one point we had this loop of testing where we just hit 0 every single time we tried to extract 2 or 20. It'd always be 0 no matter what we tried, so we weren't even sure how to test it. So that was another one of the big challenges we faced, was testing. This was our first time coding in C, a big project like this, so we really weren't sure how to approach it properly. Though we learned a little bit about it in tutorials, we still chose a more basic route of testing, which was just using print statements to debug, which isn't that smart, because sometimes even those print statements would confuse us even more than we were in the first place. So it was a lot of print statements that just kind of all bunched up into one, and we weren't sure what was going on. So
yeah, we did try using valgrind as well, especially when we were trying to make sure that we wrote into the header, or later on when we were actually writing the sound into the output file. We tried SSHing and using valgrind, so then we could see where the memory was going, because through the process we were getting a bunch of segmentation faults.
Yeah, so
classic.
Yeah. Those are the main ways we overcame that issue, but the most important way to overcome it, of course, was when we just were able to sit down, just behind us, just draw it up together on the board and actually discuss it in detail. That really helped us figure it out a lot easier than printing did.
Yeah,
that's true.
Absolutely.
That's true.
Visualization was really key in this sense, and I feel like C is a little bit difficult and not as intuitive to debug as some of the previous languages that we have encountered. And so it was definitely a lot of trial and error in seeing, how can we really test this? What values are we supposed to get? And how do we fix our program in order to get what we're looking for?
Yeah. Our final issue, as you can tell, we had to do a lot of code tracing, and it was almost more more mathematical, in the sense that it was more theoretical in trying to actually mix the samples, and I think that's one of like the biggest challenges that we've had. So as you can see behind us, our first, it's like split into two parts. Our first issue was mixing in the samples correctly, and we decided to solve that by not only creating an echo buffer to store whatever we read from the input file, but also creating a reader. And then so we would add them together in order to mix, like we would divide the buffer and we would add it to the reader and reassign it into the buffer. So then if you see from our code, it actually adds in together. So then that's the mixed sample, and that's what we write into the output file. So that was one of the biggest issues. And then the second one was actually just simply accounting for the remaining samples that aren't included in the delay amounts.
Yeah, we weren't really sure how to account for it because we knew there were a couple left over after we finished reading the file in the buffer, and we realized that we left behind some of our values in the buffer, and we skipped over and just went directly to the leftover ones. So we had to reassign those to make sure we didn't forget about them.
Yeah, it was certainly challenging when we would, play the audio, and there would be really unexpected results happening, like a significant decrease in volume or just a really weird sounding crow sound that you can hear right now. And so it would be tough trying to figure out why that was happening. And we even tried to do the CMP where we would compare the binary files and see exactly where the bytes were different. And it was very difficult trying to debug that as well. As soon as we got this assignment, we realized that this was going to be very collaborative. And so we wanted to ensure that we did everything possible to make sure that all of us were able to work on the code every step of the way together. And so the very first thing that we did was create a
One-to-meet.
Yeah, we created a one-to-meet to ensure that we were able to meet as many times during the week, given that we only had 2 weeks to work on the project, at a time that worked for everybody. And the next thing that we did was create a live share on VS Code where we could all collaborate and work on the code at the same time with each other, and that worked very well for us.
We also had our files on a shared Git repository that was private, and we worked on it individually afterwards, but most of the time when we were working on the assignment, we were doing it on live share and we were doing it together, whether it be in person or on a video call.
Yeah, so the way we sat down to tackle each of these work sessions were we'd all sit side by side, pull up our computers, and then we just go through the assignment specifications. We start with the first step and just throw ideas out there, trying to figure out how to tackle it until we kind of figure out a general path to take. Then we'd all just combine our skills into one and just work at the same time, writing up the few lines of code that we have, and then discussing where there could be errors or any issues. Then we test it all together again. We work as a group to test it with our print statements, and that was just a repeated process of just going through each issue, brainstorming, writing, testing it, all as one group.
Yeah, I think a good example of how we collaborated was that we would have live share on, and we would have all of us would be working on the same file, but then we would have different terminals. So then let's say one of us would be working in the file, one of us would be trying to test it out on our shared local terminal, and then the other would be SSH and then trying to run it with Valgrind, or trying to actually see what it looks like on a lab computer and if it were working or not.
And even all of the diagrams that we worked on, I have an entire notebook, just pages upon pages of just scribbles and diagrams that we all worked on together to really just brainstorm. And that process work was really important because it allowed us to figure out foundationally the approach that we want to take in order to code the rest of it. And overall, I feel like we ended up doing the same amount of work for each part of this assignment, which I feel like is really nice because we all equally contributed and all of our ideas are really kind of meshed into this one project, and our end result is pretty cool.
Yeah, that's true. Yeah. Also, while we were sitting together and collaborating, I think what also helped, like, if you see the notebook that Niti has, we, most of the time, we were figuring out, like, we had, at one stage, we had, like, a list of to-dos that we set for ourselves in order to, like, accomplish, like, step by step what we had to do in the code. And then, apart from that, I think what really helped was, like, when we're sitting together, when we're drawing these diagrams, and when we're even, like, trying to trace out code, we're trying to explain it to each other, and then we're trying to come up with, like, possible edge cases or possible ways that it might not work, or it might not be, like, or it might be generalized to, like, different, like, sound files, or in general, just how can we make sure that this code doesn't break. And I think that really helped, being able to, like, explain our thoughts out loud to one another.